Pardon, Nicolas, je ne sais pas si ça y te parle, mais on n'entend rien. Je pense qu'il faudrait qu'il soit en face de son ordi. Saïd, I think you have to be in front of your microphone.
It's okay now, Yasin?
Yeah, very nice.
Yeah, okay. So I think I have to sit. I don't. Okay, so in the part 2, we will discuss how to collect data for machine learning and for machine learning purpose. If you have some, for example, field data, or you have some in your application, maybe you have some points like in this part 2 we are discussing about the fire and no fire data. So maybe in your application it is different. So we will start with part 2. I think you have access to part 2. If you open the part 2, you can open your Google Drive and upload your documents from new file upload. So you can upload your, I have provided part 2. For now, you can upload the part 2. So are you open to your Google Drive? Yeah. So please upload folder upload, and you can find it part 1 here. When you upload your part 1, we have one Python document here, and also we have what we want to do in this part 1, and also some required function in Google Earth Engine. So you can open this file, part 1 Google Collaborate. Okay. So as you know, working with the Colab, you have to install everything. When you open the Colab, you have to install everything from the first. There are some ways to clone your library, but here we don't want to discuss this one. But there's a way to clone your program, and it's not possible to reinstall everything. But also, you know, there's an Anaconda with Jupyter. Maybe you have experience with the Jupyter. I want to continue with the both sides. So it is very easy. So if you open your, do you have, everyone have Anaconda here? Or no? Okay. If you don't have Anaconda, we can continue with the Jupyter, with the Colab. So, but if you have Anaconda, also you can create the environment here. Create environment in Anaconda. For example, GEE workshop. So if you have Anaconda, it is Python 9, and create your environment, and we install the Google Earth Engine and the GE map in the Anaconda. If you have it, you can create now, and I will say how to install this one. So, but we continue with we open the part 1 here. So you install the GE map. I think you installed it. Okay. Install the Earth Engine API and GE map. Got it. Okay. So you know, in GE map, it is actually based on the IP leaflet and also Folium package, and implement several methods for displaying the data, such as add layer and map center objects. The problem with the GE map, if you're working with Colab, be careful about the what you want to call from this library. If you are working with the Colab, you need to call the Folium map. Okay, if you just call the GE map, it doesn't show interactive map. Okay, because in the Colab it is based on the IP lift, so it makes some problems to show the interactive map. It is better you call in this way GE map, foil map to show your data. But in Anaconda, no problem. You can call your GE map and continue with that. So after we have a lot of codes in the JavaScript mode. In Python, we have a little work have been done. So if you find something in the internet about the JavaScript and you want to convert it to the Python, if you come to this page, here I opened this page, the Earth Engine Python API, you can see how to convert your data, your code scripts to the Python. So you can see here function, we define function in JavaScript, in this way, but in Python you can convert the Python with the these tables. So you have to remove var here, variable here. So consider these tables if you find something in JavaScript and you wanna convert it to the Python. But mainly we continue with the Python. So did you install the GMap and the Earth Engine? You can install also the Earth Engine here. In this page, I have this one. You can copy the. What's the question? Pourquoi? So here you can install the Earth Engine also. The part 1. We have a part 1, part 2. In part 1, we open this GE part 1. Right click and open with Google Colab. It's not the same. This one? Okay, you can. Do you have this one? Do you have this one? No. This page? So just write pip install. It's a GE map. If you search also GE map in the pip install GE map, it's the upgrade GE map. Yes, just write this one. You can search also in Google. Okay. So after installing GMap, you have to install the Earth Engine API. So you can Earth Engine Python API. If you search in Google, it's a Python installation. You can find this page. The Python installation. Okay, the first page is. So just copy this code. It's okay. Did you install? It's okay. Yeah. So we install GMap and we install the Earth Engine API, okay? Okay, everything is okay? Did you install? Yeah, it's okay. If you have a question, maybe if you install Gmap, you see you can see here, there's an error in the end, but it's not important. It says just restart here. Anybody install? No? Fine. Okay.
Si vous avez des questions, il faut les poser. Hein?
Yeah, if you have a question. Why you see this part 2? You can upload your driver. You have a yeah. No problem. It's French. Just I opened the French now. Just install. Did you install? It's you? It's okay? C'est bon?
Il y a un problème en particulier que vous n'arrivez pas à voir. Ah, vous n'avez pas le
In French? Yes. Okay, so that's just. I think it's the French. I opened the French version. You have an English version. But it's not important. You just need to install the library. I sent you because you can have. Okay, so here, as I said, we need to call the Gmap with the volume map. I think you will receive the update version. After that, we need to authenticate the search engine. Yes. You can just click on the link. Yeah, you can open the link for her. You can see. Thank you. So did you call the mistake? Yeah. Okay. We need to call the gmap.volume map. I think you received the new update.
Said you're muted.
It's okay.
Yeah.
Okay. So we install the G and the Earth engine. So we import this tool. You will receive the link to authenticate the Gmap. You select your Gmail account and create the token. So just copy this token to your codes. Okay. I had to. So did you receive this notification successfully saved authorization token? Yeah. I think you received the new update version also. Did you send the Nicholas? Looking easy for you? Okay. So did you receive the token here? Yes. Okay, nice. Madam, did you okay? It's okay. Okay. Okay, now it's okay. So who has a problem now? Nobody? Okay. So we need to initialize our G. Okay. So yes.
I do have an issue with the authenticate. I had a permission before, but suddenly today it doesn't let me go through.
Just install this library after that. Okay. No problem. So now we can continue. Nobody has a problem? Okay. So here, the first thing we have to do, you have to define your state area. Okay. So we have many different ways to define our state area. So here I put my coordinates. You can see my coordinates in the polygon and GeoJSON format. So there's a website that's the geojson.io. Okay, you can define your state area and export the different format. Yeah, this website, I think it's one of the fantastic websites. You can create the your state area with different formats, with KMZ format, WKT, shapefile, GeoJSON, and everything. Okay, so use this website if you wanna define your state area. You can create the rectangle from your study area and save it to shapefile. After that, we can convert all of this format to the GE, to the E objects. So Google Earth Engine use the customized version. So this website is the one of the best to define your area and export each format you want. But here you can see I just defined my geometry dot polygon and my coordinate system. But you can call also your shapefile, your WKT, and everything you want. So just run this part. Okay. So after defining did you see the study area here? Yeah, it's a fork. Yes, here you can see that it's the Fort Mackay in the Alberta. I think it's in Alberta. So this is our study area. Sorry, Saskatchewan, or it's Alberta. The between Alberta and Saskatchewan. Okay, let's go. So here, this shows that how we define the function in Google Earth Engine and with the Python version, not JavaScript. Okay, so we define our functions here, and for example, we want to extract the NDVI from the image. So this function is for extraction NDVI from the image. Or we want to define some function to mask our image, for example, cloud and cloud shadow masking, or for example, to remove or mask out the low quality observations. So we need to define the functions. So to define the function, we need to call our image, which image we wanna apply this function. After that, we say just call your bands. For example, this is for Landsat 8. Landsat 8 has a different band, so you need to find which band you wanna select. For example, for NDVI, we need to use this relation. So near infrared minus red, and division by near infrared plus red. So it depends on your function. You need to define these functions before going to your main program. Okay, we run this NDVI. Do you have any question here to define the functions? Is anything is that for you or question here? Also, after the calling, you can rename your favorite. You can rename the function to the outclass function to your favorite name. So, and just be careful when you call the function. You need to also have this part. Copy property from the image. If you don't have this part, so you will have a problem after that. You need to also add the copy properties from image to your outputs. Our output here is NDVI, and our input is the image. So we need to use this function to copy properties image to actually embed our property of image to the NDVI. So be careful about this also. we have a lot of property on the E object, so we need them after the running this function. So this function is the for sorry. As a GE object, it is not NumPy array, it is not not data frame, it is not the Python object. It is just E object. But there is a way how to convert this E object to NumPy array or X array or data frame. So this is another problem we can discuss about it. But now just consider that all thing we are talking, it's the GE object. It is on the server side. It is not on the client side. Okay. On server side, you are working on server. You apply post. You get you apply some request. You get some results. All of them is interaction actually with the server side. But if you want to bring to the NumPy, there's another issue we will discuss next time. Okay. So we defined our mask. For example, here. We wanna remove the low quality pixel with using the quality pixel. Every data set in Google Earth Engine, they actually present you also, they provide you a quality control files. You need these quality control files to remove the low quality pixels or cloud shadow. Let me show you for one of them. For example, if you I search this one, for example, in the Landsat 7 or okay, so if you go to this, for example, for Landsat 8, you can see how many bands they have, what's the name of the bands, band 1, surface reflectance, band 2, band 3. Also, always they have some other bands, like this is for example, aerosol. So this is there for bit mask for quality pixels. So if it works with, if for the bit 0, it is the fill, it's the cloud. You need this information before applying your processing. Okay, so take these notes. Actually, you will have a QA pixel file for every data set. We can see the other Sentinel, for example. So Sentinel-1, Sentinel-2, sorry, for optical data set. So you can see we have a surface reflectance. So after the bands, always we have this bit mask actually for the data set. So bits, for example, bit 10 shows that we have a close or no close, serious close. So you have to consider the this quality file data set. Also, another important thing is this scale. You need to be careful about this scale. So Google Earth Engine actually use their own scale, their own projection, their own transformation. So if you, for example, use the B2, so you have to apply this coefficient to your data set. Okay, I will show you in the coming scripts. So what is here important? Please consider the scale, consider the quality file. We will use all of them in this program. For example, one of the problem I had with it was Sentinel-3 OLCI. I realized that I was using this the Sentinel-3 ocean land cover. You can see for each band they have a scales. You see, it's very important to first look at this scales and apply to your function. For my experience, so I had a problem with the scale. I was applying this scale to my data set and I had some bad result. after communicating with support team, I realized they applied this scale, and it is not necessary to apply again. So be careful about this scale. If you don't have a good result after checking, after be sure, maybe there's some data that have a problem. Because I had the same problem, I realized that it is not necessary to apply this scale. But for the other day, I used the Moody's data set, it's okay. Landsat 8, it's okay. Landsat 7, it's okay. It was just for the OLCI data, they had a problem in this case. No, it's not. It's a scale they apply for the values. You have a value for image. Okay. The projection, you define the projection. They have actually, as I said, they use permit image for scaling, but the projection you can define in projection in which projection you wanna create your data set. Okay, but this is scale is applied for your pixel values, not pixel size or not geometry. This is not the geometry. This is the just you have to add your pixel values. Yes, yeah, actually they apply some projection. If you had a opportunity or if you had a time, you can compare the Google Earth Engine results with your local or your downloaded, for example, models. You can see they apply some scaling, especially for OLCI. I had a lot of problem because OLCI they have a 300 meter resolution. But I realized that they apply 330 meter resolution, or they use tie-by. It is just for OLCI. OLCI has actually the two coordinates, typoid coordinates and geometrical coordinates. So they use typoid coordinates. You need to be careful about this scaling. But for the Google Earth Engine, if you check about the projection, for example, scale. Let me scale in Google Earth Engine. Scale. You can see they use this image permit. When you request, for example, it should be done in 500 meters or 300 meters. They use this scale. So they build the image permit and use from this permit to create the scale. When you just define your scales, okay? It uses this permit to create your favorite scales. This scale is related to the geometrical scale, not the scale applied on the pixel values. For projection, also you can see about the projection. Basic Earth Engine design tool you have to worry about. You don't have to worry about the map projection. So they use the output main determined from the function parameters. So you can reproject your data set. You can project. Actually, you have a more freedom in applying projection and scaling in working with Google Earth Engine. So let's come back to the our code script. So we have defined the 4 function here. So for NDVI applying on Landsat 7, for NDVI Landsat 8. So we must. I think there is just need one session to display how we applied this, the quality control function. Okay, so you need to be more familiar with how bit works. So what's the 16 bits? What's the 32 bits? Okay, but for now, just consider it for the cloud mask. For example, we wanna apply the cloud shadow, cloud bit mask. Okay, so we go to the Landsat 8 on the Google Earth Engine. Let me open which data set I use. Okay, this one. I use this data set for the Landsat. If you open here I want to show you this quality pixel. So which bit is representing the cloth? Bit number 3. Yes. So if you see our script, here we say in the cloth shadow bit mask, it should be here. The bit number 3 and bit number 5 represents the cloth and cloth bit mask. So we need to put this bit number here and the bit number 5 here to extract this quality data. Okay. So just consider the bit number. It is important. You will have the bit number. Why it is the 2? Because in bit number we have each 8 bit is 1 byte. 2 power 3. We have a 8 bit. It's 1 byte. So this is related to the bit and byte. Okay. We have a 2 power 3. This is the bit location. Okay. So, and this is a bit location for the cloth bit mask. After that, when we have this mask, we have our image here, quality pixel. We call our quality pixel and use bitwise functions. I don't know, you have familiar with the bitwise function or no? No. It's a very basic operation in Python or in mathematics. You need to, for example, it's a true, false. The result is the false. True, 0, 1, 1, 0. This is related to the operational or basic, let's say, bitwise function. So we say in the quality control files, when you call the quality control files, compare it with the cloth shadow bit mask. If it is equal 0, take it. Also, and if in the cloth bit mask is equal 0, take create this mask. After creating this mask, we update our image regarding this mask. Okay, so it requires you need to be more familiar about the bitwise function in Python, how it works, and how you can apply for your data set in Google Earth Engine. If we have a different bitwise function, you can search in Google bitwise operation actually in Python. So this is based on that. It is not related to Google Earth Engine. It is just related to your knowledge about the Python. You can read this bitwise operation in Python. You can see we have here example. For example, operator is and A and B, bitwise and, bitwise or, bitwise XOR, A power B. So if you define in Python this operator, it means bitwise left shift. You need to be familiar with this operation. So this is also important when you wanna create your quality control, because when you call, it is easy in Google Earth Engine, you call your data set. It is very easy, just 1 line code. But you need to apply some pre-processing, check your cloth shadows. So it requires that you have some basic operational knowledge about the bitwise application. So here, that's about the bitwise. Yeah. Sorry? Yeah. Yes, it's removed because we update we use the quality pixel, and we just here apply the mask, cloth shadow, bit mask, and cloth. If we want to apply another mask, for example, what was the for example, we want to apply with water. We want to remove the snow, for example. Okay, it is related to the bit number 12 and 13. Okay. We need to put the power. For example, here is the bit 5 snow. I think here there is a bit. The bit 5 is cloud shadow. Bit 3 is the cloud. Bit 5 is the snow. Okay, I think here there is maybe a mistake here. So this is the. It should be power. Yeah, this 5 4, I think, yes. Yeah, this snow is the 4 5. So this one should be the snow, not the. 4 was. Yeah, you can see cloud shadow. It's okay. 4 is cloud shadow and 5 is snow. It's a 4 cloud. 3 and 4. It's 2 and 4. It was not 5. 5 is for snow. Okay. Just look at 3, just 3 and 4. 5 is for snow. If you wanna mask the snow, you need to put the 5. But there are some ways also. If you wanna mask, there are some other ways. You need to apply some operational function. So if you had more time, I will discuss about this part. Okay, let's continue with the creating classification. If you have a time, we come back to. I will show you some other scripts how to apply because it's important. For myself, I had a problem also with the applying quality control. So, but there are some other ways also. Here, just I was to show you that be careful about this process. It is not possible to in 2 hours to say everything. So after we have the same mask for the Landsat 7. Okay. Here, as I said, we apply our scale on our values. You can see this is the scale for Landsat 8. Okay. So for Landsat 8, let's go to check what's the pixel value. Is it correct or not? It was Landsat 8 scale here. Yes. Let's check which one. We have to check that at the first. We have to check the quality of the data in the Google Earth engine, and in the Landsat 7. Let me check it. Yeah, it was for Landsat 8. It was for Landsat 8, but we can check it for Landsat 7. So our data collection in Landsat 7 is this one. Okay, so you can search in the catalog, Earth Engine data catalog. So let's go to find what's the pixel values, bands. Here, bit mask, QA pixel. Well, so you can see bit number 3 is related cloud. Bit number 4 is related cloud shadow. Yeah, it was the same Landsat 8. Yes. So bit number 3, bit number 4. Yeah. So what we applied in the bit, yes, it should be changed. Yes, in mask Landsat 7 also it should be changed to 4. 5 is for snow. If you wanna mask out snow, you need to put the 5. Okay. Yes. So we run did you run all different functions here? Okay. So here, after defining your functions, as I said, we need to define the scale function for each data set. Here, you can see for Landsat 8, this is the scale we need to multiply to our data set. And but in the Landsat 7, they have a same actually they have the same scales, Landsat 7 and Landsat 8. But if you are using Sentinel-2 or other data set, you need to be careful about these scales and scales and quality control. It is very important. Two things: scales, value, and quality control. Okay, so let's go to here. Okay, how we define our time frame in Google Earth Engine? It is very easy. You need to just put your date. For example, here I am looking the Landsat image collection. Image collection for Landsat 7 from 1999 to 1990 in November, October. So we define our started date and end date. After that, we call our dataset. If you want to call your dataset, it is EE.image collection. If you write here EE, for example, we want to call LSR 7. Well, if you write EE.image collection, you can see it's easy. It brings the old function you want. Image collection, you need to ID of the dataset. So if you don't know what is the exact ID, also it is very easy. You can search it as in data catalog. We have Earth Engine data catalog. Put your Landsat here. We have a lot of different Landsat dataset in Google Earth Engine. You can see Landsat 8, 9, and so here is the Landsat. Landsat 9, 8, 7, Landsat 4, Landsat 5, Landsat 1 to 5. So for Landsat 7, we have three different, not three, actually the surface reflectance, top of atmosphere, raw image. For each one also we have two versions, Tier 1, Tier 2, Tier 1, Tier 2. So if you just in the here you can see the which. If you want a surface reflectance, you have to use the surface reflectance iris. If you click on here, you can see the Landsat 7 collection 2, Tier 1, L2 means the surface reflectance. If it is L1, it means top of atmosphere reflectance. This is the level 2 data set. Okay. Yes. If you are looking for the top of atmosphere, it is level 1 data set. Yes, they didn't apply atmospheric correction. Actually, in level 2, they applied atmospheric correction on data set, but in level 1, they didn't apply atmospheric correction on the data set. Everywhere you see the L2, it means they applied atmospheric correction on the data set. Questions? So until now, I think you need to know what is the image collection. So and what is the image? If you have one image, we say EE.image. But if you want to define the collection of image, we say EE.image collections. Okay, we call the EE image collection. But if you want to work just one image, it is the EE.image. So here I defined my starting date in the here. So ending date, and let me remove this one. So I defined my data set. So how we apply our defined function to our image collection? It is very easy. It is just with map. You need to apply when after calling your data set here, when you call your data set, so you just need to write the function map and your name of your function. every function you want to apply to all of the data set, you just write it map and your name of the functions. Okay, this means you want to apply this scale for all collections. Map, that actually, what does it mean, map? Map means you map your function for all image collection. Because of this reason, we use the map keywords for the applying our function. So if we define function like scaling or the masking, all of the function, if you want to apply to the image collection in Google Earth Engine, it is down with the map and your name of your function. You can see here in this code also we want to filter our data set. Okay, how we filter our data set? We filter, this collection. It means you have all of the Landsat 8 or Landsat 7 data collection. So you want to filter, and you want to how many filter we can apply to our data set? Temporal filter, yes. Our spatial filter, our study area, and also maybe we want to apply some functions like like scaling values and masking values, masking our data set. This line just define your collections, nothing. Just define your collection, but we need to filter this collection. The first filter we apply, we say the filter date. Don't remember to change your filtering, for the filter date to the caps lock. So filter caps lock date. I want to apply date filter. So after that, I define the in Google Earth Engine, as I said, we are working with the server side. Why we here is that EEE date. What is our date? Start demo T0. It was just a string. Yes, you can see Google Earth Engine doesn't it doesn't know that this is string. We have to introduce this string for Google Earth Engine because we are working with server. It is not your local computer. So this server works knows the data in this format. We need to convert our string to the Earth EE date. We wanna say this object is related to the date object. Okay, it's a date object, not image object. All of the string in the Google Earth Engine is it's a server side, so we need to define. You can see here we say EE.date. After that we have our string. EE.date, we have our string. You can see also the define. If you wanna looks, it's very beautiful. You can see define your here. It is more, I think maybe it's more better. So for example, here I say the define the. You can bring this another way. It depends on you how you wanna define your data set. Okay. This you wanna define your dates in this space. It's the same, but here we need to remove the. Okay, I think also this one. We have a both. I think we have a problem also here. So we defined the starting date with the EE.date. So the finishing date with the typical string file. Okay, so if you run, I think we need to. Yes, I think I forgot to put the parentheses here. It should be 2 parentheses, yes. One for this one. Yeah, it's okay. Question? Okay. So we have other filtering on the Here, Google Earth Engine objects. So this one is related to filter date. Yes. So we defined our dates. The second one is filter bounds. We want to define our steady area. Okay. So this is the filter bounds. It's the ROI. When we defined this ROI, it was the here. You can see it. Again, I don't want to repeat again. We have to define in the Google Earth Engine language. The language of the Google Earth Engine is EE.geometry, EE.date, EE. You have to always bring this EE in the in the first of the code. Okay. So we defined our polygon here, our area of interest. So we introduced our area of interest here. You can see. So we have a filter bounds, filter dates. Again, this is the caps bounds. This is the caps lock should be on. You want to write the filter. So we have also some metadata filter. Okay, so you have some metadata in your data set, in your image collection. What can be this metadata? It can be the cloud coverage, for example. When you have your image, for example, Landsat 8 or Landsat 7, in the metadata, they also mention some about the cloud coverage. Okay. So we can apply here about the cloud cover. So our cloud cover should be less than 3%. Okay, we can say in that image we need those images that the cloud cover is less than 30%, for example. Okay, so if we need something applying metadata, we need to use this function filter metadata cloud coverage. But there's one problem here. If you selected 30%, for example, for the cloud coverage, okay, so this cloud coverage is related to the all of the image, not your steady area. For example, you define your steady area. Yeah, so you say I wanna apply this. I need those pixels. The cloud coverage is less than 30%, but it considers the all image, not your steady area. Okay, so this is you can see we are applying our filter on the image collection, not your data set. So maybe one image is 50% is cloud coverage, and your steady area is located in the other side. You remove the you remove some image. So you have to visualize. You have to see where is your steady area, and after that check this color. But we can apply the filter data. So in the end, we have our map function. So if you want to filter bounds, filter metadata, so after that we need to apply our defined function. We defined NDVI and we defined our mask here, the mask Landsat 8. About the property, maybe I want to show also this one. So image properties. This is related to the filter metadata. So we have some description in Earth Engine data catalog. We have a bands, name of the bands, scales, offsets, and bit mask. Another important is image property. So you didn't ask me how you obtain this cloud cover. No, it is coming from the image property. You can see the cloud cover. This is different for Sentinel-2. It is not cloud cover. Let's see what is the name of the for Sentinel-2. For example, Sentinel-2. It is the if we want to use Sentinel-2 surface reflectance. So let's check the image property. It is the cloud shadow percentage, cloud coverage assessment, cloud feature percentage. You can see every image collection has their own image properties, has their own scales, has their own, the image quality. So when you want to call your image collection, be careful about the image properties. So it sometimes happens you just focus on your program and you don't consider just a small thing like this one. So many times it's you are facing with the errors and you don't know what's going on. Sometimes it creates one error in 2 pages just because of the small names. So please check the properties, bands, scales, everything before applying any function. So here we use the cloud cover because for the Landsat 7 it is the cloud cover. So we were here. Okay, we defined our data. We defined our data. Let me change to the 3%. Okay, so here we can extract this function also is very useful. You wanna get information about the band names, for example. You can check with these band names in the data catalog also, but here if you wanna check how many band you have, you can use get information from the band names. For example, here I want a band names, so I can use the get information to see how many bands I have here. So after defining this function, so we have another function about select. You have a lot of bands in your image data collection, but we don't need all of them. We just need 2 bands or 3 bands. Here you can see we have, I think, 20 bands for Landsat 8. We created some other bands. So we have a surface reflectance, we have a aerosol also quality. So we just need the surface reflectance from band 1 to 7 and also NDVI. Okay. We say please select this data set. You can also bring this code maybe here. If you don't want to create another code, we can put here. We say please filter our data set from filter date, filter bounds, filter metadata, map our function, and finally select these bands for me. Not all of them. Okay, I say select surface reflectance between the 1 to 7 and also NDVI. So when you selected these bands, why apply median here? What do you think? Yes, exactly. If you yes, yeah, exactly. If you see here, I defined the 4 months. Yes, it's about 4 months. My temporal time, my time window is 4 months. Okay, so it depends. Maybe you wanna define for 1 week. Maybe you need all of the image, or you need just the 1 median or average. It depends on you. It is just I wanna select the just medium of the this data collection. So I apply this median function to just select 1 image. So I convert all of this image collection to 1 image, and this is the median of the all image. So maybe you say that I want to say the first one. You can change this median to the first. You can see the first. I want the first of this image collection. I want a median. I want the average. I want to end of the this image data set. So after that, we apply our clipperia for this here because we have another code here. Okay, so let me see the Lancettes R and we map our. So for visual, let's visualize and we can discuss about visual. So here you can see we have our Lancet A, the median of the Lancet A image here. So you can select or unselect the Google Maps or image here. Okay, the Lancet 8. So do you have it now? It's okay. You can see in the map. Yeah. Okay, so for the visualization, also important, you need to define your bands. This is false color or true color bands. This is I want to show the reflectance bands 4, reflectance band 3, reflectance band 2 with the minimum values between 0 and 3. You can change also that it's because they have values. Okay, so you need to what's the minimum and maximum value you wanna show. I think it's yeah, this value, so when you have a surface reflectance, okay, it is between 0 and 1. Okay, so when you can define the between 0 and 1, no problem. But when you define the 0 and, for example, 0.5, you just want to show that it's related to the histogram, your distribution. So maybe if you select the 0 and 0.5, maybe you have a dark image. So you need to know about this scale. You can increase it's randomly you can increase or decrease your range.
But not do randomly.
Yes, we can show the histogram, and from the histogram we can yes. If you show the histogram, so you can see which value is better for the. Yeah, it's possible. Yeah. So here. We created our Lancet 8 image. Where is our Lancet 7? Hey, it was here. No? I think the title is the Lancet 7, but yes, it should be 8. Sorry. Eight, and here is the Lancet 7. So it's the same thing here. We have a Lancet 8. I think I jumped the Lancet 7. So it's the same thing. We have Lancet 7. We define our image collection and scale our Lancet 7. You know, for after a while, you will realize that there's some tricks. For example, when you apply this map here, it applies for all image collection. But if you put this map on the end, for example, it just applies to your study area. You know, so it takes load times, it takes low processing times. So you will, if you work with more precision, you will find some tricks like this. So how you define the order of your function. Which function should be the first? Which function should be the second? Which function should be the end? So you can play with this function and you can see the processing time. This, if you are working in your computer, maybe it takes time, but it's always all of the data on the client in the server side. It doesn't take more, but it is better you apply your scale or function for a small data set rather than a big data set. Okay, so let's yeah. Yes, let me The Lancer 7. Okay. Here, I just want to select one image. Median is in the statistical. We say the yeah. Oh, how many images we have? Yes, it's a good question. How many images we have? We can sell. This is our. Let me try here. Okay. So I define a new code. I wanna see how many image I have. Yes. I say I copy data collection. Get information. Yes. You can see we have a lot of information here. Okay, we need to find the size of our data set. Okay, so there was a here. You can see all of them is related to image collection. I want to see how many image I have. Just I think. Okay. So I think you have experience with the working with dictionary object in the Python. Okay. When you create your get information, it creates a dictionary actually for you. Okay. So we can select, we can see the how many image we have through the some dictionary operation here. So for example, this is the, let me yes. It was get information. Len, it was Len. I think there was a function you can find your, yes, this is 6. Okay, when you define your get information, it actually shows that you have a 6 dictionaries. Okay, so each dictionary is related to one image. Okay, one image, not bands. We have an image collection. Okay, we have an image. Inside the image, we have bands. Okay. Media, you can select just for example. You can select other array, but in the median you have a, you know, if when you select a time window, during this time window you have a, maybe your image have a clothes or it's a shadow. Then you select them, you can find a very clear image. Okay. Yes. Yes. Yeah. Bands, bits. Bits is the 1 pixel. Not bits is the related. No. It's bits is the different. Bits is the another. You don't. You just need the, what's the pixel, what's the band, what's the image, what's the image collection. Bits is related to the how to store your data in bit 1, bit 2, bit 3. So bit mask. This is the, when we talk bit mask, we want to apply some mask, or mask means you want to take out something from your image. Okay. When I say bit mask, I say with the bit operation, I want to take out the something from my image. Okay. But through the bit operation, how you want to, for example, I think if you have it here, so consider that this is your image. Okay. So this, we have a pixels. Yes. This pixel is related to cloud. For example. Okay. This is the cloud. So we want to mask out this cloud. What we do, we have the same size with the image, another matrix, I say, it's better to say, another matrix with the same size, same pixel. That is the quality control of your pixels. It says this pixel values is related to, for example, in that matrix, the values is 0 or 1. We have a quality control 0, 1, 0, 1, 0, 1. This is different from your image. Okay, we find we say if you have a float in your quality control, so apply AND function, for example, or function. It's a bitwise. So it multiplies the image and find where is our floats. You can see 1, 1, 1. When you multiply these two matrices together, okay, so your result is you have a pixels that cloud is masked out,
Yeah.
Okay.
So earlier in the code, when we were looking at the information, and we were looking at the 4 and the 5, like the
Yes.
spaces for black.
Yeah. It was just like it just doing like this.
So the function POW,
Yeah.
the position of it in the
Yes, the position of the word in the matrix. Yeah. So as I said, you need to. If I have a time, I will show you something to more understand about how you apply your quality control matrix on your image. But just consider now you have a different matrix for quality controlling, and you have a different matrix for your image. Through the operational bitwise operation, you find this mask and get out from the image. Okay. So we now have our Landsat 7, Landsat 8 image. So we extract NDVI. So we are going to apply classification. How many classification we have? Supervised classification and unsupervised classification. In the supervised classification, you need to collect training data. But here, first of all, I apply the Cummins unsupervised classification. You can open the data. You can open this code, Cummins Landsat 7. Image collections. I think something I made a mistake here. I changed something here, I think. Okay. It's not okay. So I randomly take a training data set from the Cummins. So we have so in Cummins you have to define your how many class you have. Here I think I have a 6 class in my data set. You can define 5 or 4. I started with I find the 6 is better, but in the Cummins you need to define the seeds actually. Okay, so here the seed is the 6 and the scale is the mar. Here this scale is the pixel size, not scale you apply on your values. Here scale when you're working with the image collection. So this scale means your pixel size. But we discussed about the one scale, about applying your scale and values. We apply that scale with the map function, not like this. Okay. So we apply the map function to our data set to apply our numerical values. Here you define your just pixel size. Okay. So I initialize my seeds. After that, let me show so we have a cluster. Again, if you wanna use the classification in Google Earth Engine, don't forget EE cluster. Okay. We have a lot of functions. So you wanna apply clustering. So it is, for now, it is already exists in the Google Earth Engine. Okay, so code, maybe it's better I show you some code editor. For JavaScript, Google Earth Engine have a code editor. Okay, this is the environment. I think you are familiar with this environment. Okay, here you can see we have some. You can search about your data set here. For example, as I said, we have, if I search Landsat 7, this is another way to find your here Landsat 7 collection. For example, you have you can import your data, but this is a JavaScript. I don't wanna discuss here. This is for JavaScript. We are working in Python. But if you find some JavaScript codes, you can use this JavaScript here. So we have some. You need to define your area here. It's the same with we have some doc here. You can see we have in docs we have a lot of Earth Engine functions. EE geometry, EE image collection, EE kernel, projection, reduce. For example, in classification, EE cluster. So how many cluster unsupervised classification we have? EE cluster, Weka means EE, cobweb, EE, and X means, or classifier. Let's check the classifier. Classifier, we have a SVM here, smart card, and random forest. So we have a different classification in the Google Earth Engine. You just know what's the functions, and you can apply in your scripts. Okay. So as I said, we have a lot of or EE array. This EE array actually converts your EE object to array. I think, Farzam, you asked about the converting the object. Yes, there's an EE array. You can see. You can apply this EE array. This converts your Earth Engine object to the NumPy array. Okay. So we have so if you wanna define the arc, sinus, arc, tangent, so we have bitwise here, bitwise not, a lot of functions here, or many algorithms. So we have algorithms, feature, data driven. So you need to check also we have some confusion matrix. You know, if you wanna check the accuracy, couple coefficient, we will do here. Okay, so if you wanna export something, export image, export map, export table, export video. Maybe you think some page they create some animation from Google Earth Engine. They use from export video here. It is just one line code. You can see in the one you see the changing of NDVI, for example. So it is just from the one line code. You can use it for I think NDVI. I was variation. I think I don't remember here. I just wanted to show you. Was here, I think. No. Yeah, it was a one video that shows the NDVI is variation in the. It was just about using one line code. Okay, you can find it. Okay. So what we do here, we say we select E cluster. How we find this one? So let's check from Google Doc here. You can see the cluster. Where was that? Okay. Okay, classifier for the super cluster. You can see Weka means. Yes. Okay. All of that is function coming from JavaScript side of the Google Earth Engine. So you need to also have a more small. If you don't like, for me, I don't like working in JavaScript because it needs more parameters to. For example, you need to apply for variation. You need to define what type of your variation. But I find it very interesting some function in JavaScript rather than Python. So you, as I said, you can find in JavaScript. Because of this reason, it is better you have some basic knowledge about the JavaScript, how to run your code in JavaScript. After that, you can convert easily each function. If you have a JavaScript, it is very easy to convert in your Python programming. Which one you prefer, Python or JavaScript? No. Oh, it's okay. So here I clustered my image. Sorry. You can see this is my classified functions. Okay, it was 6 class. The water, you can see the water in the. You can define what is the color. For example, here the color should be blue, but it is the default. It is about magenta. Yes. Yeah. So you can change this function, no problem. It's very easy. You can change these schematic values. So until now, we have applied defined our image collection, image, and we applied the unsupervised classification. The next step is how we apply supervised classification. So we need to collect training data. Yes, important. But this is 5 minutes for this. So you, I have 10 minutes. Okay, I think it will finish after it's completely finished. So the part 2 is reminding me. It's just what part 1. Yeah. Yes, in part 2 also it was important, but anyway, so let's continue with how we collected training data for Google Earth Engine. So we applied our collected data to the yes. Yes, yes, I can show part 2. Yeah, it's okay. So do you have a question now? Any questions? It's okay. Do you have this image? No? Why? So for this part, so we define it. Okay, let's go. I think it's a very tough time. So for me, I just have every time I want to teach something, I just have 45 minutes energy. After that, it's going to die. Okay, so I am working in the die mode now. But for you, I hope you are more better than me. Okay, so we can apply the same comments for Landsat 8. Okay. Classification dirigé en français. Dirigé means supervised, yes? Yeah. Okay, so we applied the classification, Cummins classification. It was unsupervised for the Landsat. You can see this is the for Landsat 8. This is for unsupervised Landsat 8. So let's go to the supervised vision. So you know, we said EE image collection that is working with the raster data set. In Google Earth Engine, if you want to work with the shape files or vector data set, the command is EE feature collections. Feature collection means you want to introduce your shape files for the Google Earth Engine. Okay, so I defined my shape files here. Okay, so I will after finishing this code, I will show you how I connected this training data set from Google Earth Engine because it's important. Okay, so we have this training data set here. We suppose that you know how we collected this training data set, but I just wanna show you a little about this collection training. So you can run. I think you don't have this data set. Yes. Yeah, because I had a plan to collect the data here, and you can see so just to as a repeat. So if you open in the part 2, okay, in part 1, sorry, in part 1, requirement functions, okay. This is the code. You can copy this code, okay. And did you open just the code Earth Engine code? Code Earth Engine this here, and copy this code here. Google Earth Engine code editor. You can search in Google Earth Engine code if you don't have this page. Okay. Here. Code Earth Engine editor. Okay. You have this page. So just copy that scripts in the required function here. This is what we did in Python. It is actually in JavaScript. Okay. So, but here I want to show you how we collected training data here. So just remove this sign from the first. Okay. So you can see here we had the same in the JavaScript side. So if you run these codes, maybe you will have some errors. Sorry. Scale factor, let's see, I think. Unexpected token sometimes. I see. Do you have the same error, unexpected token? No? Yeah, okay, sorry. Okay. I forgot, I removed the first one. Okay. So this, as I said, this is related to the JavaScript ones. So I don't want to go more deep here because I just want to show you how I collected data. So in Google Earth Engine, if you want to collect data, so here you have some create new, you can see here, new file, new folder, new files. So if you define the, here, we need to apply. So this geometry you can see here, rectangle. For example, this was our data set. For example, it was our data area. So here you define the new layer. Okay, new layer. For example, you want to collect data for water. Okay, so for water, you say the name of my class is water. Okay, so the color is blue. And geometry here, it's a feature collection because if it is just one point, one polygon, it is feature. But we want to define the multi-polygon, multi-points, so it is a feature collection. Okay, we had the same idea in the image. If we have one image, it is the image, but we have a multi-image, it's the image collections. And here it's the image feature collections. So for the training data, I did the same thing. So okay, so I said it's a feature collection. Property, it's the property. I defined some metadata. For example, the number of class, it is the number class value is 0. So we want to export this data set to our machine learning approach to supervise. So in there, we need to say which class, what is the name of this class, what is the value of this class. So I define the water. So after that, I just collect my data. For example, here is the water. I collected some water data. You can see. Okay, water collection. And you see that here it's 9 points. So you can collect every training data from the your study area. If my study area was here, so I need to turn off, for example, this geometry and and collect my data from here. For example, this is the water. So this is for water. For example, if you have vegetation, you define your vegetation class. Okay, vegetation. Okay. So the geometry is feature collection. Properties, the property is veg, and the value is the 1. So you define the value 0 for water. Okay. So and it's okay. So if you have a more class here, again new layer. What's another, for example, forest? Yeah, exactly. So forest. So property is the forest. Value is 3. Okay. So now you have the forest water. I think I replaced the water. Forest I didn't collect it. So for if here is the forest, no. You can remove if you want to remove the one class, you can remove for the forest. For example, it is in the forest. You collect your data here. Even you can collect in the rectangle. This is the training data. Actually, in the training data, we have a rectangle. So it depends on you. If your data set is the endpoint, or you want to collect in rectangle, polygon. So it's the same thing. So I collect it's the forest, for example. So I create a new layer for vegetation. Yeah. So if you just one point, you have 1 pixel. When you define a rectangle, you have about, yeah. If you have a homogeneous area, it is better you use rectangle. For example, here, as I said, for example, vegetation, feature collection, property class 4. Oh, sorry. Okay. So here you can see you have a big area of the land. So you can select a big data, a big area. Yeah. So you can select you have an option. You can select a polygon maybe. You can see. You can select polygon. Okay, you have an option here. You can select maybe it's a route, for example. You can select a path, Okay. But here, typically we use the point or rectangle. It's maybe you have a GPS information, so it's a point. So you need to use the yes, you can import that. Yes, you can import. This case is for when you don't have a field data. If you have a field data, you can introduce. But it's not possible to collect training data from, for example, your state area is all Canada. So you can import this field data for land cover or like this, okay? So here, so I collected in this way. So there is a, just from this code, what is important, you can see when I create the feature collection, you can see here, we have a geometry, water, and forest, vegetation, like this, okay? From this code, what is important for us, it is the export. How we export here, you can see how we export this collected training data to the shape files. This is this function. Export the table to Drive. Drive means your Google Drive. Okay. So description, the name, I put the T for T0 training data set, and file format is the shape file format. Okay. So just consider this one here. To run the old code, I need to change all of the variables, but we don't have time more. So just consider this. I exported this state feature collection to the shape file. Okay. So you can see in the code we have maybe you cannot enable to see its results. Okay, so I run these codes. Here I can see my samples. I need to define. I run the again. Sorry. Yes. Okay. Okay. After creating your training data, we need to. Here you can see we have our training data set. You can see I collected in the point mode and converted here. Okay, I have my data set here. So training data, you can see the all training data, they convert all of them to the one data set. So after having your training data, we can continue for the image classification. So we have a class, and so in classification, we need to define our training data set. You can see this is the 80% for training data, 20% for testing data. I have it here. So we have a training data feature collection for the we have a same training data for, we need to define the same training data for Landsat 8. It was just for Landsat 7 because we had a two image for Landsat 7 for 1990, Landsat 8 for 2000, I think 20 it was okay. So I collected training data for the Landsat 7. We have a same procedure here. So training data set for Landsat 8. So I just want to go to the classification here. So in the classification, after defining the your here, again we defined our classifier. In the previous, for the unsupervised classification, we use clusterer, okay? But here we define the EE.classifier and random forest, okay? This code is coming from, if you don't know where is the random forest, as I said, you can go to the here docs classifiers. If you forgot, for example, the name of the random forest, you can go to the doc and you in the classifier you can find the, for example, we have a decision tree also. We have a SVM also. Okay, you can use the each of this function to define your random forest and SVM. Okay, so I use the random forest here. I define the number of trees. So I want to classify my image. So I think I need to showing the map in the in the Colab. It's very, you need to define every time the. So where was the map here? Okay. So you can see here the result of the map. This is the supervised classification. That's Farzan. After the collection training data, you use the random forest classification here. Okay, random classification. This is the random forest classification. So we define our training data from our feature selections. Okay, so we have our bands. Which bands we want to use? This was the how many bands we used here. This is the L7 bands. If we see the Landsat 7 bands, yes, here was the. So it's the Landsat 7 bands was. We have a Landsat 7 bands. So we applied our classification here. We applied our random forest classification for the Landsat 7 bands here, and this is the result for the classified image. So for Landsat 8 also we can do the same thing. So how we evaluate our classification? With testing data. If you remember, we selected the 80% of our training data for image collection, for training data. Here you can see we have some training data and testing data. I can train data, I think test data better. Test data. So I have it here. data. So here it was the train. It was Landsat 8. Sorry, it's for the Landsat 7. Here it was the training data. After classification, we can check our accuracy, evaluation the classification. So we have a test data. For which classification? For classification of random forest. Okay, so we can test accuracy print. So I think we need before the training data, everything is okay. Test accuracy, test training data, classify random forest model, random forest model. Oh, we didn't define here. Okay. This is for Landsat 8. We are looking for Landsat 7. Okay, here. So if you see here, we have our random forest model. We use the classifier random forest, training data, and label and Landsat 7. Okay, so we add our classifier. So for evaluation, I think we need to apply the evaluation, the classification. So okay. I think we have some mistake in defining the function. But for evaluation also we use the error matrix, the test accuracy for produce our confusion matrix. This code is also for the producing the confusion matrix. So Nicholas, how many times we have? Okay. Yeah. Okay. So I had a plan to collect the training data from the Google Earth Engine. Yeah. Yes, I think for the training data, yeah, I selected the randomly training data. Okay, so yeah, it was for randomly selection data. If you select the accurate training data, you can see your confusion matrix here. Because we didn't have time to select the exact training data. So if you collect your training data accurately for each land cover, you will have a good confusion matrix here. Okay. So this was for the part 1. I tried to show you how you call your Landsat 7, Landsat 8, apply supervised or unsupervised classification. Okay, how you collect training data from Google Earth Engine for your supervised classification. So in the part 2, I just wanted to show you what we wanted to show in part 2. So if you part 2.1, it's actually if you open the part 2.1. Okay, so here I think you have English version maybe. Okay. Okay. After installing the GE, because we have to install again, so GE map, and after installing that, you will have. I need to show you just the results. Okay. Authenticate. You can run also the. You can run the part 2.1. Just quickly, I want to show you the results. The Gmap is installing. Okay, continue. Oops. Create token. So we create our token to run the part 2. Okay, authorize. We have a GE map again. So here, just use our part 1 GE map to use the to import the GE map. As I said, if you're working with Anaconda, you don't have problem with showing the maps. But if you work with the Colab, as I said, we need to import this function instead of this. Okay, GE map with the full. We wanna work the GE map with the volume map. Okay, so import and so here in the part 2, consider you have some collected data, but it is not related to the land cover. It is maybe the GPS information, maybe you want to say that it's the fire, no fire, land sites or no land sites. You have a just location of the location of the one happening, for example, fire, land sites, flood, for example. You have a just position, but you don't have information from the satellites. You want to connect your field data. It is not training data. It's what training data is free. Training data we just have a land cover data, but this field data is related to your application. It can be flood, land site, and any data. You want to connect this data set to image data set. Okay, so you can extract some information from satellite image like NDVI, like NDWI, water index, vegetation index. You wanna actually you wanna make a relationship between your field data and your satellite data. Here, so here we have a you have your okay. So if you go to your file function here, you need to mount your. If you put the disk driver, you mount your Google driver to the Colab. Okay. When you put this mount drive, you see that this is script. You run this script and connect to the Google Drive. Okay, just 5 minutes. Okay, so we install some requirement from the where is the requirement function here? Content, drive. Yes, my drive. The workshop. I have a part 2. Requirement. I copy paste here, copy paste, and define for the if you uploaded the part 1, part 2 in Google Drive, you can find your if you mount your Google Drive to the Colab, you can find in the content. You can see in the bin boot in the content, your Google Drive is going to the content. Okay, in the content you have a drive. In drive you have your My Drive and your file. For example, here for me it's the G workshop part 1, part 2, and in the part 2 I had a one document. To apply this function, you need to have this pass, copy pass, and define it for the Colab. So here, this one's okay. So for example, I want to read my CSV. my text files. So what's the name? Habitable fire. So this is the fire case. They are happening in the fire data set. So this one is the should be located in shape files. You have your shape files. Here is the which one? This one, okay? You have a database of the fire. We define the database here. So you can, okay. This is your database, okay? You have a latitude, longitude, time, and you can see latitude, what's the land cover here, what is the NDVI, what is your NDMI, and the other feature you have from your field data, okay? How we connected this data to, so you can read all of this shape file in your data set. So how we relate this after calling this database, we called our machine learning approach here. You can see we want to apply, for example, regression function. We use this regression function here. So or if you want to classify between the forest and the fire and the non-fire, we can use this database for classification approach and regression function. It's okay, Stephanie? Yes. So yeah, thank you. Just for the part 2, also we have another part 1. Sorry, I had to show because maybe they want to use it. Okay. So here in part 2, you have also another Colab file. Okay, so this is the same thing. We collect we collected the training data, sorry, the data set. We introduce our database, and after that we use the machine learning. So this is our database. You can see we collected from Google Earth Engine. We had the latitude, longitude, and we added some NDVI from the Google Earth Engine and created database. This database go to the part, another scripts to classify or apply regression. That's okay. So if you have more questions, it's okay. But as I said, the problem is with the time. But if you just take the part 1, I think you can work with the Google Earth Engine very precisely, and it's very useful if you wanna use the Google Earth Engine. That's okay. Yeah, you can. If you have questions, if you when you run this script, if you have questions, don't hesitate to write any emails. My email, I think they have my email. It's okay. Yeah, you can send it. If you have questions, if you want to work with the Google Earth Engine, you can ask, especially from the part 2. I had a plan to explain the part 2. I suppose that maybe I can be more fast, but it doesn't happen. So that's it. Thank you. Thank you so much. Yes, Yasin?
Yes, Said.
Yes, are you there? It's okay. So we are.
Yeah, thank you very much for this presentation. I think people have now all the knowledge to run the rest of the material. So it's interesting to have more than less as script, as codes to I think it's useful for the project if they need to adapt something they have ready code and tested code. So it's interesting. Merci. Merci beaucoup, Said.
Thank you so much. So as I say, when you run the program, if you have problem, just write an email. I can answer, no problem. Have a good day. Thank you.
Like students they meet like here at the and stuff.
I just tried to bring everything to in the training, but I think but I tried to cover the.
Yeah. For the people that are online, I don't know if you've heard, but we're gonna have like basically a 1 hour lunch break. So we'll start again around 1:15.